Find the equation of circle when 3 points are given, when 1 point given and 2 intercepts x and y are given. Concyclic, finding the value of c when 4 points are given to you, one of the point is 0, c. And after that, we have done direct common tangents. Find the equation of direct common tangents. And then I gave homework for transfer common tangent with the explanation that what is the difference you have to mention while solving the problem, transfer common tangents. Today, we will move to the question number 20th most important problem. That will be the question number 20 of your exam, coming exam. I'm asking about the coming exams. Question number 20. 18, 19 expected problems we have done. Now we will do the expected problem that will take on the place of question number 20 of your exams. What is that? Look at here. Most important problem, derive the standard form of a parabola that is y square is equal to 4ax. This is our question today, the most important question of parabola. What is this? Simple. Derive the standard form of a parabola that is y square is equal to 4ax. This is the standard form of a parabola we have to derive. Okay. Conic section, parabola, hyperbola, ellipse, lattice rectum, focus, that this all the basic things. Hope you have already learned for the first time. This is the y square is equal to 4x. We have to derive. How? See here, first, be careful while I'm drawing the diagram. So here is the solution, or you can write proof. See here, we have y square is equal to 4ax. This we want to derive. First thing, I'm drawing the here diagram to prove this particular condition. Look at here. This is y-axis, or you can take directrix. This is y-axis, and this is x-axis. X-axis, y-axis. This is my directrix. This line, the fixed line is called directrix. Okay. Represented by L, capital L. Okay. This is a point of locus. Let P of x1, y1. Just I'm drawing a line here. Here, this is a fixed point called focus, a, 0. I am extending this part that is called as projection of P. These are all things you have to mention. I will write what are the things I'm using here. I'm going to write after the diagram. Don't worry. This is M. If I draw a line perpendicular like this, okay. This line I'm naming it N. From here to here, okay. This and this are equal. Means if I take this as A, this should also be A. Okay. And this much distance. Here, it is the vertex of parabola. You know that this is the parabola drawing I am. Okay. This is the vertex of parabola. I am representing with A 0, 0. Okay. 0, 0. A 0, 0. This much distance from N to A, just I am writing as x1. And this is the point of locus on parabola x1, y1. And this point I am naming it as Z. Okay. In order to derive the standard form of parabola, we need to take the help of this diagram that I have drawn here. See here, this is locus of a point on the parabola. Name it as P x1, y1. Okay. This is y-axis and this is x-axis. It is a fixed point called as focus. Here, the extended part, projection of P from here, P to M. This fixed line is called directrix. Okay. So what are the things we have used in the diagram? I'm writing here. Very, very important, each and every step. See here. In the above diagram, this S, A, 0 is the focus of parabola. A fixed point that is called focus. Next, A 0, 0 is the vertex of parabola. Vertex of parabola. Next, P x1, y1 is the locus of parabola. Okay, locus of parabola. Next, L is the directrix. Yeah. L is called directrix of parabola. Yeah, this directrix is also enough. So all the things which I have mentioned here in this diagram, I have indicated each and everything. Okay. Now coming to the problematic part of this derivation, look at here in the diagram. PMZN forms a rectangle. Yeah. Yes. Since PMZN forms a rectangle, forms a rectangle. We know that in a rectangle, opposite sides are equal. So I can write PM is equal to NZ. Okay. So PM is equal to NZ. PM is equal to NZ. Here N and Z is there. Okay. From N to A is X1 and A to Z is A. So this NZ I can write NA plus AZ. Okay. So this I can write NA plus AZ. What is NA? NA is X1 and AZ is A. So I can write this as X1 plus A. So this PM I can write as X1 plus A. Okay. PM I can write as X1 plus A. Now, coming to the next part, what is the distance between P to S? Yeah, SP you can say or PS you can say, whatever it may be, right? PS. So we have to use the distance formula, that is SP is equal to root over X1 minus X2 square plus Y1 minus Y2 square. So here X1, Y1, this is X2, Y2. X1 minus X2 here is A, X2 is A. So I can write here I can write SP is equal to root over X1 minus X2 square, that is X1 minus A whole square, X1 minus A whole square plus Y1 minus Y2. Y1 is Y1, Y2 is 0. So just you write Y1 minus 0 square. This is the according to the distance formula for these 2 points, P and S or SP. So here you can write X1 minus A square plus Y1 square. Okay. Now, by the definition of parabola, what we have, we know that if the eccentricity or eccentricity of conic section is 1, then only it is called as parabola. So here I can write by the definition of parabola. By the definition of parabola, I can write SP by PM. SP by PM is equal to 1. This also I can write SP is equal to PM. Okay. PM into 1 is PM. What is SP for us? Just now we have written here. This is the value of SP. So I can write here root over X1 minus A whole square plus Y1 square is equal to PM. What is PM for us? Yeah, PM is X1 plus A. PM is X1 plus A. Just write it in a so PM is X1 plus A. X1 plus A. So now just I'm doing the squaring on both sides. Squaring on both sides. Oh, what we are getting if we do the squaring on both sides? Root over X1 minus A square plus Y1 square is equal whole square is equal to X1 plus A square. This square and root get cancelled. So we are getting here X1 minus A square plus Y1 square is equal to x1 plus a whole square. Okay, so now we have to expand these particular terms according to a minus b whole square, and this is a plus b whole square formula. According to that, we need to expand. Just check once again this diagram. If I have any doubt here, so I'm going to rough it. Please check it once again. Have any queries, can ask. I'm going to rub this part. If you do not have any doubt. Now look at here. X minus a whole square according to a minus b whole square, that is a square minus 2ab plus b square, or you can write a square plus b square minus 2ab. So according to the formula, that is x1 square plus a square minus 2a x1 plus y1 square as it is plus y1 square is equal to a plus b whole square, that is x1 square plus a square plus 2a x1 according to the a minus b and a plus b whole square formulas. So x1 square, a square get cancelled. What we are having? Y1 square minus 2a x1 is equal to 2a x1. Just send minus 2a x1 to right hand side. So what it will be? Y1 square is equal to 2a x1 plus 2a x1. This I can write y1 square is equal to 4a x1. Therefore, the locus of parabola is y square is equal to 4ax. This is our derivation, finally, what we have got now. Okay, please check it once again. From that till here, we have continued from here. From here, we have continued here. Okay. If you have any doubt, you can ask in the comments. That's just now I am checking it. If no doubts means we can go to the next most important problem for the 7 marks of the same chapter, parabola. It contains one LAQ and one VSAQ. As we are dealing with the LAQs, when we deal with the VSAQs, we will teach you what are the important. VSAQs can become for the parabola, from the chapter parabola. चले रफ I'm going to give you similar problem as homework that you have to do by yourself. Let's see some more problems. I'm writing the problem on the board. You just copy it. Then we will solve it. Most important, very, very important. Prove that the area of the triangle inscribed in the parabola inscribed in the parabola y square is equal to 4ax if one by 8a mod y1 minus y2 minus y3 minus y1 square units where y1 comma y2 comma y3 are the ordinates of its vertices are the ordinate of its vertices. Very, very, very important for 7 marks. Very important. Then I'm giving the problem for homework that also you have to do. First, we will solve it. Look at here. What is the problem given to us? Prove that the area of the triangle inscribed in the parabola y squared is equal to 4ax. Noted down the point. Inscribed in the parabola y squared is equal to 4ax. Okay. Is 1 by 8a, y1 minus y2, y2 minus y3, y3 minus y1 under mod square units, where y1 comma y2 comma y3 are the ordinates of its vertices. Ordinate means the value of y-axis, the position of y-axis. See here, we will solve this problem with the help of a diagram. Look at here how to draw the diagram and what is the diagram and how to solve it. First, solution. Given that y square is equal to 4ax. This is given to us. And by using this particular condition, we have to derive the square, the area of the triangle inscribed in the parabola is this. What is this? What is the condition? See here, we are having a parabola. Okay. This is x-axis and this is y-axis. Okay. And just, it is a parabola. This is the parabola. Here, what is asking, in this parabola, we have drawn a triangle. This is a point, another point, and this is another point. Just join these two. P, Q, R. So it is asking you to find the area of this triangle inscribed in a parabola. This is actually our problem. Okay. Let me draw this more accurately. Okay. We need to find the area of the triangle that is inscribed in a parabola. We have to show that the area of the triangle PQR is this. That is our question. Okay. So this I have drawn the diagram. Now we will solve the problematic part. Diagrammatic part is over. In this diagram, in the above diagram, PQR is a triangle. PQR is a triangle inscribed in a parabola. In a parabola, y square is equal to 4ax. Okay. See, if these are the points of a triangle, vertices of a triangle, okay, so I'm taking that this parametric form, that is, this I am taking from parabola parametric form. Let P of x1 comma y1 is equal to a t1 square comma 2a t1. This is my first point here. Next, Q x2 comma y2 is equal to a t2 square comma 2a t2. R x3 comma y3 is equal to a t3 square comma 2a t3. Okay, these are the vertices of triangle that is inscribed in a parabola. Okay, we have to show only the ordinate forms. Only means ordinate means only y-axis here. These all are in y. Okay, so how to find the area of the triangle? In basics of 10th class, you have learnt already area of the triangle is equal to half mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y3. The same way, we have to use here one more formula according to find the area of the triangle. I'm using that formula. Area of triangle PQR is equal to half, yeah, or you can say 1 by 2 mod. This is also simple formula. X1, Y1, 1, X2, Y2, 1, X3, Y3, 1. Okay, very simple formula. You can easily remember X1, Y1, 1, X2, Y2, 1, X3, Y3, 1, followed by 1 by 2 here. Okay, so X1, Y1, X2, Y2, X3, Y3, I have already taken. Just we need to substitute here. See here what we will get. So 1 by 2 mod X1 A T1 square A T1 square Y1 2A T1 1 as it is. Next X2 A T2 square 2A T2 1 Y3 A T3 square 2A T3 1. So all the values with respect to the points I have substitute here. Okay. Now, is it visible? Yeah, it is visible. Yeah. So now just look at here. From this first column, I am taking A common outside. And from the second column, I am taking 2A common, taking outside. So what I will get? So I can get 1 by 2 from the first column A into A into 2A. I'm taking outside finally from here and here. So what I'm getting here? T1 square as 2A or 2A is outside, just T1 is left. This one remain as it is. From here, T2 square, T2, 1 as it is. Here, T3 square, T3, 1 as it is. So these two and these two get cancelled. A into A is A square. So in numerator, what we are getting? We are getting as A square, keep it as it is. Okay, see here. This particular matrices form, just I am applying some row operation in order to get this result. Okay, what are that? Very simple, two operations. R1 tends to R1 minus R2. I'm subtracting first row with second row. Next, R2 is equal to R2 minus R3. Second row, I'm subtracting with third row. Okay. So this simplification form is what we have got. 2 to get cancelled, A square. So R1 minus R2. T1 square minus T2 square. Yes. T1 square minus T2 square. Here, T1 minus T2. Here, 1 minus 1 is 0. Next, R2 minus R3. And what I'm getting? T2 square minus T3 square. Here, T2 minus T3. 1 minus 1 is 0. The third row is unchanged. We have not applied any row or column operation to the third row. Keep it as it is. So T3 square, T3, 1, keep it as it is. See here, this is in the form of A square minus B square. And this is also in the form of A square minus B square. So according to the formula, A square minus B square, what is the formula? A minus B into A plus B. We are using the basic algebraic formula. Okay. If I convert according to the formula, what I will get a square is equal to a square mod a minus b into a plus b. T1 minus T2 into T1 plus T2. This T1 minus T2 as it is. This 0 as it is. Now, same formula we have to apply here. What is this? T2 minus T3 into T2 plus T3. Here, T2 minus T3. 0 as it is. The third row remain unchanged. T3 square. Here, T3, 1. Okay. From here, look at here in the first row, I can take T1 minus T2 common. First row. Okay. So what I left? T1 plus T2. And from the second row, I can take T2 minus T3 as common. Keep it outside. So what we will get? A square in the bracket. T1 minus T2. One option. Okay. And from the second row, T3 minus T2. Okay. Remaining terms as it is. What are the remaining terms? T1 plus T2. T1 plus T2. It is outside, so just 1, 0 as it is. It is outside. What is left? T2 plus T3. T2 plus T3. This is outside. 1, 0 as it is. Again, T3 square. T3, 1. Okay. So all the steps are more and more in simplified way. Each and every step I have included here. I have to rough this complete part in order to continue. Just look at once from the beginning. Shall I rough this? Yeah, we can rough. Anything can be useful for us. Yeah, this all is useful. But in the solution I'm asking, I think we do not need. Keep it as it is. Remaining part we can rough. So now, a square, T1 minus T2, T3 minus T2 as it is. No change in that. Just make a boundary. Is equal to a square T1 minus T2, T3 minus T2. Okay. What is the common we have taken here? T2 minus T3. Not T3 minus T2, just little bit rectification. T2 minus T3. Here also T2 minus T3. Okay, from the second row, we have taken T2 minus T3 common. Okay. Now, look at here on these matrices. I'm starting finding the determinant of the matrix from these column, last column. If you are choosing 0 from here, okay, if I have to find the determinant from here, okay, so this row and this column leave and find AD minus BC. But 0 into anything is 0. Yes. So just I'm writing 0. Minus again, leave these rows and column. 0 into anything, 0. So the term which contain non-zero elements, only this. Hope you are understanding. So if I find that mod form, that is AD minus BC, 0, something I will get, minus 0, something I will get. I'm starting finding determinant from here. So 0 into anything, 0. So leave it 1 plus 1. See here, if I'm taking here plus 1, this row and this column should be leave AD minus BC. T1 plus T2 into 1, that is T1 plus T2. T1 plus T2 minus BC. What is BC? 1 into T2 plus T3. In the bracket, T2 plus T3. Brackets are very important. So now what we are getting? A square in the bracket T1 minus T2 and T2 minus T3. This again the forms. Simply, this all things are 0. No need to worry about it. Leave it. Now, T1 plus T2. T1 plus T2 minus T2 plus into minus minus T3. So, this and this get cancelled. You will get T1 minus T3. Okay. So, I can write A square T1 minus T2, T2 minus T3. See here, T1 minus T3 I am getting here. If I take minus common, T3 minus T1. Okay. But the mod of minus again positive. So you just understand carefully. T1 minus T3, if I take minus common, T3 minus T1 will come. Okay. Just what I'm doing, mod of this again positive. So no need to worry about this negative sign until unless you have security of mod. So just
excuse me, sir.
Yes, ma. Now you are audible to me. Please ask.
I can't see the board clearly, sir.
Unable to see the board. Just the
Yes.
first query I got. Please do some changes. Just now you got this problem or from the beginning?
From the beginning, I'm saying.
So you have to inform me. Each and every step should be visible clearly to the students. Because how many changes are coming here? So you want me to use black? So I can use, not an issue. Usually we use black for the question and blue for the solution.
Yes, sir.
From where you have joined us, ma?
From Temri, sir.
Okay.
Now it is clear, sir.
Yeah, it is clear. It is clear. Okay. See here, we are dealing with the most important problem of the parabola. Before solution of this problem, we have completed standard form or derivation of the standard form of a parabola. Don't forget that. Very, very important. Okay. So now, here in the problem, just once again, I'm telling, we have to show that if a triangle inscribed in a parabola, then the area of that inscribed triangle is 1 by 8a under mod y1 minus y2, y2 minus y3, y3 minus y1. Okay, square units. This we are proving. If you rewind my video, you will find the diagram. Each and everything was clearly I have explained. Even then, you can ask directly now also. So shall I proceed further?
Yes, sir.
Okay. See here what I have done here. T1 plus T2 minus T2 get cancelled. T1 minus T3 I got. If I simplify it, you should not write this. Just for your understanding purpose, I am telling. If I take minus common, T3 minus T1 we will come. But with the security or with the presence of mod, you don't worry about this negative. You can write just T3 minus T1. Okay.
Okay, sir.
Yeah, just you write with the pencil. At the time of practice, you maybe remember it. Remove the mod and remove the negative sign. So at the time of practice, it will be very helpful. So this I am writing. This complete step I will write with the pen, black pen. So a square T1 minus T2, T2 minus T3, and remove the mod and remove the negative sign. So you will get T3 minus T1. Okay. So this complete we have got. Okay. In order, see here, this T1 minus T2, T2 minus T3, T3 minus T1. Okay. What I'm doing, this each and every step, I'm multiplying with 2a in numerator, 2a for the first terms, 2a for the second term, 2a for the third term. So 3 times I have to multiply, and the same time I have to divide 3 times. So what I'm getting? So a square divided by this from my side, 2a into 2a into 2a. These 3 times I'm multiplying in denominator. So for the area purpose, write mod. Okay. So 3 times I'm using 2a, 2a, 2a. So in the same time, in the bracket 2a, T1 minus 2, T2, first time, again into 2a, T2 minus T3 into 2a, T3 minus T1. Okay. Here, 1 time, 2 time, 3 time. 1 time, 2 time, 3 time. Got the same things we have to multiply in numerator and divide in the denominator. That is okay. Now take this 2a inside. So what we are getting? A square as it is by 2 to the 4, 4 to the 8. A into a square into a is a cube. Under mod 2a T1, 2a T1 minus 2a T2, right? Here 2a T2 minus 2a T3. Again here 2a T3 minus 2a T1. Ordinates. Only ordinates we are getting. Only the position of y, not x. Coordinate means x and y. Ordinate means only y-axis. So what is this? y1. If you see the after the diagram, let p x1 comma y1 is equal to that. P of x2 comma y2 is equal to that. P of x3 comma r of x3 comma y3 is equal to that. Something I have written. So according to that, if you compare, this is the position of y1 minus y2, y2 minus y3, y3 minus y1. Okay. So here square, a square get cancelled, just a is left here. So I can write 1 by 8a. So this is equal to 1 by 8a mod. This is y1 minus y2, y1 minus y2 into y2 minus y3 into y3 minus y1. These are the required conditions that we have to prove. Therefore, the area of the required triangle PQR is equal to 1 by 80. Same thing. y1 minus y2 y2 minus y3, y3 minus y1. Hence proved. If I'm audible to you, please just let me know till where you have understood. Yes, anyone?
I understood whole problem, sir.
From the beginning, have you understood?
Yes, sir.
Extended form derivation of parabola.
No, sir, I was not there.
If you have link, you just go back. Please, extended form of parabola is very important problem. Do not leave it.
Okay, sir.
Derivation of extended form of parabola, the most expected problem. And this is the area of the triangle inscribed in a parabola. If you have link, you just rewind the video and check that. Okay. Now, look at here. Some of the most important problems. Yeah, we have more 5 minutes. I'm giving as homework. You please do it. Do not leave it. These problems you have to please practice what I'm going to write on the board as homework. I'm referring this all. These lengthy solutions require much more time to understand and to explain. But once you practice, you can represent all the LAQs in exam just within an hour. Have you followed my previous videos, circles?
No, sir. This is my first class.
My timing of class is 11 to 2, 11 a.m. to 12 p.m. So please try to be on time. Circles, I have solved already the most important problems that will take the positions of question number 18 and 19 in your section C. And this will, the problem which we have solved, the most expected problem will take the position of question number 20. Please do not miss any class. This I'm giving as homework. Please solve it. Homework problem. Sometime it asks. If you face any type of problem, just at the time only you inform us. Look at here. Find the coordinates of the vertex and the focus the equation of directrix and axis of the following parabolas. The first one, y square plus 4x plus 4y minus 3 is equal to 0. And the second one is x square minus 2x plus 4y minus 3 is equal to 0. Listen here, focus, lattice rectum, okay, and the axis of parabolas. These all things are usually comes in VSAQs. Sometimes they gather two problems for LAQs. So take this problem as homework, solve it. If unable to solve, please send in the comments. We will solve it. Okay. One more thing, those who are new to this class, today's class, please, we have started first LAQ sections. I said in my first class, circles, parabola, integration, definite integral, differential equation. These 5 chapters, most important LAQs first we will do. Then we will move to the SAQs, section B. Then VSAQs. This is the way we have planned to teach you. So first our focus on LAQs. Got circles LAQs we have completed, and today parabola most important LAQs. Hope the standard form of derivation of parabola in standard form will come in exam. And one more thing, find the area of the triangle inscribed in a parabola. Okay. And with that, you have to do this. And if possible, videos are available on the YouTube. You please check. Max to be by Hakeem sir. From the beginning, first video till today. Okay.
Yes, sir.
Practice, practice, practice. The only one way that you can achieve your dream, only practice. If have any kind of doubt, please pass the comments. Just while solving the problem, sometimes I check anyone have any ask any doubt, or as you are audible to me, I am audible to you. So this is the way. Got? And once again, to everyone, I'm telling, tomorrow we are going to do the calculus part, that is integration. So please be on time, attend the class on time, and integration, you know very well how is integration. Okay. So tomorrow, most important LAQs of integration we are going to solve. Today's the most important parabolas completed. Day before today, circles. Okay. So in integration, we are having 2 LAQs that inshallah we will do. Okay. So thank you for joining us, and please take the advantage of these services provided by Shaheen Academy to all the students. Okay. Thank you. Have a nice day.